Right. Right. You saw my previous video about the 3 coil system. So I'm going to record this video instead of doing it live because it's gives you a chance to pause it probably. Right. So I've actually designed and I'm currently printing a 7 coil system, and I'll explain the benefits of the 7 coil over the 3 coil. One of the benefits is that I don't have to invert any of the coils. That is, I don't have to wire any of the coils backwards back to front, because the switching, the work is done by the extra magnets. So say we've got north on this side, we've got north on the opposite side, and we've got south in the middle. Well, when south is directly above all of the coils, that's basically our top dead center. So all of the coils are basically energized with a single pole, and they're all in series. Now what happens is, as the rotors move in and as the south field actually moves out of the way, and let's say it's over here somewhere round about there. Now when the south field is over here, then the north field starts to come into play, basically switching out the half of the coil set. And so we have basically what do you call basically a cancellation effect. So now the reason for the 6-7 coils is, when we're at top dead center, we get maximum output, and instead of having drag as a particular pole is leaving the coil arrangement, we would normally have drag. We would have a reluctance to leave that area. But because the north field is entering the other half of the coil set, what we have is attraction. So any drag, any inducement or inducement of a field on the coils that creates a drag effect would equally be transmitted through the coil set to create an attraction on this side. So we would cancel out the drag. That is the theory. Anyway, that's the principle what I'm basing this. So these coils would basically be wired in series. So I didn't want to draw these all in because it makes it look a bit messy, but you get the idea. They're all in series, and instead of having a switching, it's passive. It's instead of using an external switching system, it's all done passively by the actual rotor magnets as they're entering and leaving. So let me just simplify it a little bit. I mean, I'm sure you're getting the idea, but let's just put a dot for each coil. So we've got 1, 2, 3, 4, 5, 6, 7. So we've got 7 coils. Now I'm just doing a dot because it's a lot easier to see what I'm doing here. So and we have south. Let's put an X let's just put an S for south and an N for north. Right, now if half of the coil set is exposed to a north field and the other half of the coil set is exposed to a south field, we have cancellation. We have no output, so there is no drag. There can't be any output if there's no drag. I mean, if there's no drag, we won't have any output. So there's no drag, because if one coil is inducing a drag effect, then there's going to be a voltage through these coils. One half of the coil set is going to be induced by a north field. The other half of the coil set is going to be induced by a south field. There's going to be voltage flowing through the coils, but the overall, the way they're all in series, the overall output will be naught. So we would have no volts coming out. Right? No volts coming out means no drag. You get the point? If there's no output when both the south and the north are over the same set of coil sets in series, how can you have a drag effect? You can't, because it's balanced, right? So anyway, and as the south field moves out of the way, let's just say south is over here. I'll put a little cross, And let's say north is now over here. Let's put across. Now south is actually out of the way. North has come into full effect on the coil, on all the coils. They're inducing a voltage now. So instead of 0 volt, we now have our maximum voltage, which probably is going to be in the region of 70 volts because I've got 7 coils. It's probably going to be higher than that. And based on the 3 coil set, which I had about 80 milliamps, I had roughly 80 milliamps on the 3 coil set. So I'm expecting to get somewhere in the region of 160 milliamps, somewhere around about there. So anyway, that's an update, and that's the new design I'm currently doing at the moment. More information and details will be appearing once I've got that printed and built, and I'm currently printing the coil holders at the moment, and they're pretty big. They are very big. Anyway, so more to come.